Hello friends, welcome to Study Make Education channel, and today we are going to discuss about MCQ for Mechanical Engineering part 5. So let's start. Our question here, break-even analysis consists of, our options are A. Variable cost, option B. Fixed and variable cost, option C. Operation cost, and option D. Fixed cost. Our right answer over here, first of all, that is option B. Fixed and variable cost. As we know, the total cost is equal to fixed cost plus variable cost. Sometimes in exam the MCQ will come like break even point consist of, at that time our answer should be it is the intersection of sales revenue line and total cost line. As we know, what is total cost? Total cost means fixed cost plus variable cost. Okay, now let's see what is sales revenue line and total cost line in this diagram. As we can see here, the green line shows that total revenue line means sales revenue line, and black one is total cost line. So our intersection point is known as break even point. So remember this difference. Now the value at break even point, there is one equation, F upon V minus V by P. So here F is the fixed cost and V is the variable cost and P is the selling price. Remember this equation. Now there is another equation that we have to remember, that is EOQ. EOQ stands for economic order quantity, and the equation is twice AP divided by I square root. Here I is for inventory cost, P is for purchasing cost, and A is for annual cost, we can say. So remember this both equation, very important equation. So now let's move to the next question. Well, our question is maximum MRP indicates. Our options are material requirement planning, option B material reordering planning, option C material requirement program, and option D material recording point. So our right option is over here, material requirement planning. Option A is the right answer over here, material requirement and planning. First of all, as we know, MRP stands for maximum retail price, but over here our answer is material requirement and planning. Now some another term, that is recording point. Let me zoom over here, recording point. Now recording point in industrial engineering, it is also known as B plus S plus R. Now what is B, what is S, and what is R? Let's see. B is stand for, S is stand for, and R stand for. S is stand for safety stock, R is stand for reserve stock, and B is stand for buffer stock. Okay, so remember this, the recording point is stand for buffer stock plus safety stock plus reserve stock. So remember this is an also very important for exam point of view. Now let's move to the next question. Well, our next question is seam welding. Seam welding is a process of option A multi-spot welding, arc welding, thermite welding, and option D continuous spot welding. So first of all, as we know, seam welding is a type of resistance arc welding. In resistance arc welding, there is a spot welding, there is also multi spot welding and continuous spot welding. Continuous spot welding is known as seam welding. Let me clear all of this. Continuous spot welding is known as seam welding. Okay, so our right answer is D, continuous spot welding. Now the another option given here, thermite welding. Thermite welding is a type of arc welding, remember. Now let's see one by one what are the types of welding. First of all, arc welding. Arc welding is also known as fusion welding. Fusion welding, and the temperature in this welding reach up to 6000 degrees Celsius to 7000 degrees Celsius. 7000 degrees Celsius. Remember this. And over here, as we can see, straight polarity and reverse polarity. Now for straight polarity, if electrode connected to negative, or we can say connected to cathode, and our workpiece is connected to positive or anode, then this type of arrangement is known as straight polarity. Now in reverse polarity, if electrode connected to positive or anode and workpiece connected to negative or cathode, then this type of arrangement is known as reverse polarity. Okay, now another point is unshielded and shielded welding types. So for unshielded, large electrode or filler rod is used for welding, remember this. And for shielded type welding rod coated with flux material. Why? Because to prevent welding rod against atmosphere, or we can say in another words, to prevent welding rod in contact with an oxygen. And this process is used for mild or low alloy steel, remember this. Now arc welding process, very important. CAW means carbon arc welding process. In carbon arc welding, the welding electrode are made from carbon plus pasting material. Now pasting material is used for to binding the carbon electrode. Now next is MAW, metal arc welding. In metal arc welding, as we know, electrode made by metal, or we can say the electrode metal is similar to the base metal, remember. Now next is MIG. MIG stand for this one, metal inert gas welding. Now inert gas that we are using here, it is helium and argon. Remember, helium and argon both are inert gas. The inert gas means not reacting gas. Now one more thing that we have to remember for metal inert gas welding, that it is consumable electrode process. Let's move to the next detail. TIG stand for tungsten inert gas welding process. So here the inert gas use argon and helium, that we know. Now over here, in tungsten inert gas welding process, alternating current is used for steel, cast iron, aluminium and magnesium, and for direct current use is for copper alloy and stainless steel. Over here, stainless steel is also known as high strength steel, remember this. Now let's move to the next detail. Another thing that we have to remember for TIG, and it is very important for MCQ purpose, that TIG is known as non-consumable electrode welding process. Okay, now let's move to the next detail. Atomic hydrogen welding. In this process 2 tungsten electrodes are used. Next is a submerged arc welding process. In submerged arc welding process, it is also known as bare metal electrode welding process. Now what is bare? Bare means naked, and in technical word we can say without cover or without shield. So in this welding process bare metal electrode are used. Now next is thermite welding process, very important, thermite welding process. Now what is the meaning of thermite? The meaning of thermite is mixture of iron oxide and aluminum oxide is known as thermite, and temperature over here is 1500 degrees Celsius. Now to convert Celsius into Fahrenheit, we have one equation, C is equal to 5/9 F minus 32, F for Fahrenheit, C for Celsius. This is an additional information. Now in thermite welding process, all parts of the weld section are molded at the same time and cools uniformly. So what is the benefit of this? The minimum internal residual stress will be generated, so that is good for the product. And this process is used for iron and steel parts such as rails, truck frames, locomotive frames, stern frames, broken gear teeth, etc. Now what is stern? To understand stern, we have to go in the topic of ship. As we know, the front portion of ship is known as bow and the rear portion is known as stern. And let me draw the small diagram of ship. Just assume this is a ship. If we look from left side, so we can draw this figure. Like my drawing is not so good, but let me try. Well, the front portion is known as bow, and we are looking from back side, the rear portion, so this is known as stern. And if we look from rear portion or back side, then right side of the ship, this is the right side, right hand side of the ship is known as starboard. Remember this. And if we look from rear side, and the left hand side of the ship is known as port, P-O-R-T. Remember, the right hand side is known as starboard, and left hand side is known as port. Okay, so over here back to our point is the thermite welding is used for stern frame welding process. Now this information I think enough for this MCQ. Now let's move to the next question. Our next question is, the process layout is employed for. Our option are A, continuous type product, option B, effective utilization of machine, option C, all of the three mentioned here, and option D, batch production. Always remember that process layout is employed for batch production. So our right answer is here D, batch production. And let's move to the next detail, product layout. Product layout is always employed for mass production, while process layout is employed for batch production. Okay, let's discuss next detail. Process layout is also known as analytical layout, and product layout is also known as synthetic layout. Okay, and another detail for process layout and product layout, that we have to discuss over here, that process layout is used for tools and gauges. You can also pronounce gauges. So gauges and gauges both are same. Process layout is normally employed for tools and gauges process, and product layout is applied for automobile sector. Remember this. Now bearing balls. To make bearing balls we have to use both product and process layout. Means bearing ball required combined layout of process and product. Remember this. Okay. Another detail is fixed position layout and static production layout. Now fixed position and static production both are same. So let's take an example for aeroplane, for ship, for submarine, for large boiler. It is required to use fixed position layout and static production layout. Now another information over here that we have to remember: line, staff and functional organization. Line organization, it is also known as rigid organization, and that is used in a military sector. As we know, military sector is very rigid body, so line organization is used in military process. Now in automobile both line and staff organization are used. Remember this. And in a steel company there is line, staff and functional. These three organizations are used. So remember this. Now let's move to the next detail. Our next question over here: an engineer, let me zoom over here, an engineer hammer is made of, our option are A, cast iron, option B, bale metal, option C, high carbon steel, and option D, gun metal. First of all, our right answer is for hammer we have to use high carbon steel, and for high carbon steel our carbon percentage is 0.8 to 1.5 percentage carbon percentage is available in high carbon steel. Okay, now let's discuss all other options in brief. So let's move to the details given over here. Cast iron, as we know, cast iron is a brittle material, and cast iron, then next stainless steel is a ductile material. Okay, that we know. And for cast iron, for brittle material and ductile material, there is another important term, that is stress concentration, that we have to remember. For the case of stress concentration, if static load is come into the picture, then for stress concentration is very serious in static loading condition for brittle material, and the stress concentration for cyclic load, it is very serious in ductile material. So remember friend, in a ductile material stress concentration is very serious for cyclic load, while in a brittle material stress concentration is very serious in static loading condition. Remember this. Now let's move to our main topic. Well, bale metal is the composition of copper and tin. Okay, so the percentage of copper are 78%, and the percentage of tin are roughly 22. Remember this. For bale metal, the composition of A is copper and tin, and the percentage of copper is 78% and percentage of tin is 22. Now next is high carbon steel, that we know. We have already discussed about high carbon steel. Next is a hexo blade. Hexo blade is made from high carbon steel, and there is another power saw. Power saw is made from high speed steel. Remember. Now next is gun metal. Gun metal, the composition is copper, tin and zinc. The percentage of copper are 88%, the percentage of tin are 10%, and the zinc is up to 2%. So remember this. Now bearing ball. Bearing balls are made from chrome steel, and next is measuring tape. Measuring tape are made from flexible steel or high carbon steel or high quality steel. Now lathe bed. For lathe bed we have to remember over here, lathe bed are made from grey cast iron, and for grey cast iron we have to remember one more thing, the contraction or shrinkage. The contraction or shrinkage for grey cast iron are 7 to 10.5 mm per meter. These are the additional information. Remember this. Now let's move to the main point. Lathe bed are made from grey cast iron, and it is also hard by flame hardening. Remember this. Flame hardening. These details are frequently asked in an exam, so remember these details. Now let's move to the next detail. Crank hook are made by wrought iron, WROUGST, wrought iron. And for wrought iron we have to remember, wrought iron is 99.98% iron, Fe, and 0.02% carbon. Remember these values. Now let's move to the next detail. Railway coupling are also made from wrought iron. Next is connecting rod. Connecting rod is made from medium carbon steel. Okay. Now flywheel. Flywheel we have already discussed in our previous video. So for flywheel it is made from, let me clear all this. Flywheel made from grey cast iron. Remember, flywheel and lathe bed both are made from grey cast iron. Okay. And the spokes of flywheel have to deal with tensile force. We have already discussed this matter in last previous video. And next details is screwdriver. Screwdriver is also made from medium carbon steel. Now cold chisel, very important. Let me zoom over here. Cold chisel are made from cast tool steel. Remember, cold chisel are made from cast tool steel. Very important. Now the shape of cold chisel is like octagonal. So 1 2 3 4 5 6 7 and 8. 1 2 3 4 5 6 7 8. Okay, this is the cross sectional of cold chisel. So remember this. Now cutting tools are made from high speed steel. Okay. Now next is high strength steel. High strength steel is known as stainless steel. Remember this, stainless steel. I think we have discussed a lot of for this question. So let's recall the answer of this question, that an engineer hammer is made of high carbon steel. Remember this. Okay. Now let's move to the next detail. Oh, this is the end of the video. We will continue upload our next video, so to be continued. Press like button if you like the content given in the video, and also give comments because your feedbacks are very important for us. Share it with your engineering friends like mechanical, automobile and mechatronics, etc. Don't forget to subscribe this channel, and to join with our next video, please subscribe this channel. We are also available on Facebook, Twitter, LinkedIn and Google+. If you have any query, then you can feel free to contact us, and you have any suggestion, if you have any suggestion, then you can directly contact us on studymakeeducation@gmail.com. Thank you. Have a good day.